Direct current motors, presented by Brian Chu. When electricity was first discovered, it was a fascinating new topic for neophysicists. How could the energy of electrons interacting be viable and so intriguing? With the further development into electricity, scientists could now harness the electricity to automate mechanism and components, making work more efficient and removing the burden of manual labor. One such development would be the motor, an attempt at automated motion.
This model is how the scientists first imagined the motor. Here we've got our two bar magnets, north and south pole, and now here we have two wire extenders. Here we have our armory, and between the wires and the armory we have carbon brushes extending the currents through the armory as it rotates, as being a motor. Now if we apply the currents to the armory, we can see here that demonstrated that using Fleming's left-hand rule, this being the force, this being the direction the motor turns, this being the magnetic field, and this being the current direction of current, is applied here. You can see, applied here, you can see that the armory rotates clockwise, this way, this way, resulting eventually, as it keeps turning, into this diagram. Now this diagram, the arm has rotated 90 degrees, and now it is now perpendicular to both magnets, and the wires are still feeding the current. Now we reach the problem. As this side keeps going, it appears that the magnetic field, demonstrated here, the magnetic field will stop it from actually crossing the magnets and will keep bouncing back and forth, as it cannot cross it, as it doesn't have enough energy to cross it, or momentum to cross it, as the magnetic field is working against it. This is the problem of the first motor that the scientists drawn up.
The currents within the wire first gave it motion, but now worked against the wire's path, stopping it from doing a full rotation and being a motor, as the magnetic fields repelled each other. And so they came to a solution of using a direct current motor, or more specifically, the commutator component of a direct current motor.
This is how a direct current motor, or DC motor, works. This is a diagram of the inside of a motor. First, these are two bar magnets, labeled north and south. This is commutator, whose purpose I shall describe later, and this is the armor, the part that rotates within a motor. These two are wires connecting to the commutator, and between the wires to the commutator, there are carbon brushes which transfer the currents from the wire to the commutator. Now, as you apply current to the wire, coming in this way and exiting there, the armory shall now experience torque and shall move in a clockwise fashion into this diagram. Let's move clockwise fashion. Now, the brushes remain in contact despite the fact that it's turning, and it will eventually result in this diagram. Now, in this diagram, the armory is perpendicular to both magnets on either side, and there is no connection between the brushes and the commutator. Now, the commutator will continue turning clockwise due to momentum from the previous turnings. And previously, as seen in this diagram, now this commutator here, which I shall label with this orange mark, was receiving current, and this was releasing current. Now this commutator here remains neutral, and both of them are neutral. But however, as it keeps turning, this commutator, which I previously labeled, takes out the currents while this brings in the currents. This allows the armory to pass the bar magnets without being pushed back, and to allow it to continue spinning, like a proper motor. Eventually, coming back to our first diagram, as it is rotor, and will keep turning until this current flow is stopped.
Solution. Now, with the application of the commutator enables the current in the armature to be switched and its polarity to reverse, therefore allowing the motor to spin the magnets and come around for another rotation. Now, advantages of this solution. The structure of the direct current motor allows for the current to directly influence and therefore control the speed of which the motor turns at a very precise level. This is why the DC motor is often used for the finer components. The simple setup allows for easy use directly from the battery. There are no other components besides the ones that stated that are necessary for the use and the function of the motor. There are little parts to hinder the mechanism or draw power from the source. Therefore, the draw on currents is proportional to the load on the armature. And now, disadvantages of the solution. It is a high maintenance cost. Care must be taken with the treatment of the mechanical interface of the commutator. The brushes of the commutator used to transfer currents are the most fragile parts of the components and are susceptible to force as well as heat and other influences, as well as split circles that form part of the commutator. The components of the motor are vulnerable to temperature changes and will expand and contract. This event will mess and affect the design and buildup of the commutator, rendering it less efficient. With the precision of the DC motor, it allowed the electrical movement of a wheelchair, giving its user the ability to go wherever he or she wanted. This allowed disabled people to lead longer, more fulfilling lives, as they were no longer as dependent as they were on others to help them as they were before.